Syazwani binti Risam, and this is my research presentation for my research proposal titled Multiple Linear Regression Analysis on the COVID-19 Effect on Rice Production in Malaysia. I chose this title as I can see how COVID-19 has dramatically affected every industry in Malaysia. One of the industries that were affected was the agriculture sector. Hence, I chose to focus on the rice industry as there was less coverage on the future of the rice industry in Malaysia after the COVID-19 wave. Now, in Chapter 1 of this research proposal, I would go on the details of the proposal in 5 sections, that is, the background of the problem, problem statement, objectives of the study, scope of the study, and significance of the study. The background of the problem for this proposal is that COVID-19 has left an impact on the rice production in Malaysia. When the COVID-19 virus hit, Malaysia decided to implement the Movement Control Order MCO on 18 March 2020. By Statista, Malaysia reported a decrease in rice production by 0.37 million metric tons in 2020. The Movement Control Order was one of the contributors to this downfall. If Malaysia continues to let this happen, it may need to import more rice from other countries to meet the needs of its citizens. On 27 May 2022, Thailand and Vietnam decided to raise the domestic rice prices, but does not intend to restrict rice export. Even if Malaysia has its rice industry, Malaysia still relies heavily on imported rice. If other countries decided to raise the rice prices, and with the decrease in rice production due to COVID-19, Malaysia would face a food crisis. Hence, a forecasting tools such as the multiple linear regression would help Malaysia to predict their rice industry future. The COVID-19 had restricted much producing work in producing rice. By research made by the Food and Fertilizer Technology Center for the Asian and Pacific region, the agricultural producers had difficulty in marketing their agricultural produce and products during Movement Control Order. Factors that lead to the issue were limited market issues, transportation and distribution issue, increased marketing management costs, delayed orders, and product shortage. All of these factors appear to be related to the Movement Control Order. Therefore, a multiple linear regression analysis could help predict rice production by taking into account more than one factor, as any factor can be added as a new independent variable. The objectives of the study are to predict the effect of COVID-19 on rice production in Malaysia using a linear regression method, to identify the most suitable regression model to estimate the rice production in Malaysia, and to verify the multiple linear regression accuracy in being a forecasting tool using the data from the Department of Agriculture, Malaysia. This research would be conducted by using the data obtained for each month from the year 2019 to 2021. Kedah was chosen as a model data since it is known as the largest contributor to rice production in Malaysia. Kelantan, Perak, Sarawak, Perlis and Selangor were chosen as the comparison model. The data used for this research will be obtained from the Department of Agriculture Malaysia website. The data when the paddy harvest is in the main season will only be considered. According to the paddy cycle, the data from December until April were the most suitable to use. This study is to be conducted to know the future of rice production in Malaysia after the COVID-19 wave. This is important to avoid any future shortage of rice in Malaysia. Other than that, it is also important to avoid job loss for the farmers working in the rice industry. According to Alam, considering that Malaysia has its rice industry, recorded that 0.3 million Malaysians work as a paddy farmers in Malaysia. Hence, it is crucial to not let the farmers lose their source of income. The findings from the study could help Malaysia prepare for another crisis in their rice industry. Moving on to Chapter 2, Literature Review. This part of this research proposal will give an overview of the simple linear regression and the multiple linear regression and some research made for forecasting rice production by other researchers. Simple linear regression is the most basic regression analysis where it only depends on one independent variable. An equation such as equation 1 has been yielded by its assumption. Then, the multiple linear regression is the extension of the simple linear regression method. While the simple linear regression only depends on one independent variable, the multiple linear regression allows the user to apply more than two independent variables in the formula. The multiple linear regression equation is just like the equation 2 in the slide. There is another rice production forecasting method other than these two methods. In a study conducted by Rahman in 2010, the ARIMA approach was used as a forecasting method for boro rice production in Bangladesh. The time series data of local, modern, and total boro rice production were modeled using a Box-Jenkins type stochastic autoregressive integrated moving average ARIMA process. The study concluded that the ARIMA 012 is the best fitted model. Other than that, a study used fuzzy time series in estimating the rice production of the farm of GB Pantmasiti, Patnagar, India. In this study, a new method of fuzzy time series were proposed where 13 fuzzy was served as linguistic variables on redivided intervals. In a conclusion, it is found that the new fuzzy time series are more precise and dependable methods for crop production, estimation, and prediction. Afterwards, a study on rice production had been done using the multiple linear regression method. The study by Norden uses multiple linear regression on conjugate gradient methods. Four independent variables were set for this research. That was paddy production, planted area, human population, and domestic consumption, with one dependent variable that is rice production. To ensure that the four independent variables chosen can predict the dependent variable, SPSS was used to perform multiple regression analysis on each independent variable. The research concluded that the conjugate gradient method is reliable. It is also found that the four variables chosen are significant to rice production in Malaysia. The variable used for this research will be the same as the study before, with two added factors that are labor and wages. Next, Chapter 3, Research Methodology, will explain the procedures used to analyze the data in this study. The multiple linear regression with equation 2 has 5 assumptions on it that are a linear relationship between the dependent and independent variables. The independent variables are not highly correlated with each other. The variance of the residuals is constant. Independence of observation and multivariate normality. The least square method is used to find the best fitting line for the parameters. According to Dania, it is implemented by minimizing the sum of squared deviations between each observed and predicted value. It entails solving a series of concurrent normal equations, one for each parameter in the model. There is two evaluation methods that will be used to evaluate the quality of the model in this study. The mean squared error is used by squaring the distance between the point and the regression line. By Glenn, the squaring is required to remove any negative sign. It also gives more weight to larger differences. The lower the mean squared error, the better the forecast. Then, the R-squared and adjusted R-squared is the other method. R-squared is a statistical measure that represents the proportion of variance explained by an independent variable or variables in a regression model for a dependent variable. Meanwhile, adjusted R-squared is a modified version of R-squared. Among this method, adjusted R-squared was chosen to evaluate the multiple linear regression forecasting models in this study. According to Koch, across all conditions, the positive part version of the most widely used adjusted R-squared estimator performed best in terms of both maximum and average in the mean-squared error perspective. Lastly, the research planning and schedule of the study are shown in the slide. In this research, I expect to see the forecast model compute the same results as the model data or at least almost the same value. Other than that, it is anticipated to see the linear relationship between the independent variables and the dependent variables. This could help depict the relationship between the independent variable and the dependent variable. Hence, we can identify the factors that will affect the rice production post-COVID-19 the most. I also hope that this study will help the rice industry in Malaysia. Rice has been a basic necessity for Malaysia for a long time. It is important for the Malaysian government to secure its future so that no other new wave of COVID-19 could disrupt the industry. Therefore, to help control the downfall of rice production, a forecast model would be of service to implement any protecting steps from another downfall. This is the end of my presentation. Thank you.